So we're going to be going through the inverse functions section of the trigonometric graphs, Unit 11. When you're talking about inverses, it means that you switch your x and y values, which is what we're going to do here for the graphs. But there's actually a little more to it than just that. So when we want to know the angle, when the sine, cosine, or tangent of the angle is known, we use the inverse functions. On the calculator, these are indicated by sine to the -1, cosine to the -1, and tan to the -1. Another notation is to use the word arc, A-R-C, in front of the function. I don't know why that is. The math geniuses that were developing all this stuff decided that arc would be a good thing to put in front of it. So, in your calculator, they look like this, with the little -1s. But verbally, when you say it, you read it arc sine, arc cosine, and arc tangent. So this is how it will be in your calculator. This is how I will be saying it for the remainder of the video and the rest of the year. Just like you should. When you get into college, it'll make you sound smart, and your professors will be impressed. So we read arc sine. When you read that, it actually means the angle whose sine is x. So they're talking about, when you use arc sine, this is going to be the sine value of it, not an angle measure anymore. Notice it's not a theta, it's now going to be some number. So early we were learning that the graphs of the inverses of functions can be formed by reflecting through the line y equals x, or switching the x and y values. So when this happens, we know that sine of 150 is the same thing as sine of 30, which both of those equal 1/2. And if you needed to, you could do that in your calculator. You could do sine of 150, and it would give you 1/2. You could do sine of 30, and it would give you 1/2. Therefore, two ordered pairs of the same sine function are 30 1/2 and 150 1/2. And since 2 points have the same y value, but different x values, this is not a function anymore. Oops, sorry. This is not a one-to-one function anymore. Functions which are not one-to-one have inverses which are not functions, which you'll be able to tell in just a second when we get to the graphs. So, if we want to graph y equals sine, arc sine of x, normally your sine graph looks something like this. It starts at 0, goes up, down, and it does a curve kind of like this. But now, we're going to switch our x and y values. So we should start with our axes. Oops, it's a bad one. So start with our axes. And we do know that sine starts at 0. So our first point should be at 0. Now, our x's and our y's have switched. So on our x-axis now, we're going to have 1. I should do those in black. 1, and we'll have -1. And on our y-axis, we're going to have pi over 2, pi, 3 pi over 2, and 2 pi. And the same thing going down. Negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. So when we graph them, pi over 2 would normally be at 1, pi is back at 0, 3 pi over 2 is at negative 1, and 2 pi is at 0. You can continue that pattern backwards, like so, and then you can sketch your curve in here. So this is essentially the sine curve, but it's going vertically now. Some of those weren't such great curves. So we have a vertical sine curve. Now, you'll notice that if I am to draw a vertical line through here, yeah, it's not very vertical, that this would hit 1, 2, 3, 4 times. So it's important to note this is not a function. Just like the next two. So we're going to actually graph, for the next part here, we're going to graph cosine, but the inverse of it, so arc cos. So we'll take our axes, and I'm not going to label these this time. So I have 1 and negative 1, pi over 2, pi, 3 pi over 2, 2 pi, negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. And we know that cosine starts at 1, goes to 0, down to negative 1, back to 0, and back up to 1. And does the same pattern in the negatives. So our cosine graph should look something like this. And again, if we drew that vertical line, you'd hit 4 times, and you could do it on either side. So again, this is not a function. And the last one here is going to be the tangent graph. The last one was cosine, this one is tangent. So we have our axes, we have our marks, and this one's going to look a little bit different because the tangent graph, we know, if we were to sketch the tangent graph, it looks something like this, where it comes down through, and there's asymptotes in here now. So it looks something like this. It's a little funny. Our asymptotes, the important thing is that our asymptotes are here at pi over 2 and at negative pi over 2. So if I go ahead and draw an asymptote at pi over 2, draw an asymptote at negative pi over 2, and at negative 3 pi over 2, and at positive 3 pi over 2. Now I know that my graph goes through 0 at these other points. So it's going to come down really close to the asymptote here, curve in, and go down really close to the asymptote on the other side. And that's going to repeat for each one of these. So do your best to draw them each. So your tangent graph should look like that. And again, if I were to draw a vertical line anywhere through here, change the color of that, if I draw a vertical line anywhere through here, it's going to hit multiple times. So again, this is not a function. Sometimes, though, as this next part says, we can limit the domain of the inverses from negative, so that it's from -1 to +1, and the inverses will be functions. So arcsine will only be a function when the angles are between -2 pi and +2 pi. So arcsine, the graph would look like this. You'd be going from -1 to +1, positive pi over 2 to negative pi over 2. So essentially you would just have this one little piece going from here to 0 and down. You'd have the one little piece that looks like this. So this is from negative pi over 2 is less than or equal to x is less than or equal to pi over 2. Arc cosine is a little bit different, because if we were to do that over the same area, you would have the piece that goes like this, and that repeats already. So we don't want that. Instead, we're going to go from 0 up to pi, because now we start here, go to 0, go to -1. So the graph looks something like this. So for cosine, if we want the inverse to be a function, it would be from 0 is less than or equal to x is less than or equal to 1 pi. And for tan inverse, arctan, we need to have a piece where nothing repeats. So we know that arctan has asymptotes at pi over 2 and negative pi over 2. So that pretty much outlines exactly where our tan function would be before it repeats. So arctan is going to be the same as arcsine. So negative pi over 2 is less than or equal to x is less than or equal to pi over 2. So what this is doing is this is taking out the other pieces of the graph. So for sine, it would be the piece of the graph that loops back down in this direction. So now if I draw a line through here, we only hit the red piece once, because we've limited how far we're drawing our graph. Same thing goes for cosine. This is the piece that would curve back like this. So again, if we drew a line, now we're only hitting the red part once, because we've limited what part of the graph we're drawing. And for tangent, this would just repeat over. It would do something like this. So we've, again, limited where that goes, so we're only hitting one part of the graph. So it can be considered a function now on this limited domain. That's what this is actually called, a limited domain. So I would definitely make these sketches in there somewhere, even if they're small, just so that you know exactly what's going on. All right, for these next three parts, this is actually where you're going to be doing a little bit of calculating. So you would use a calculator for this. So the first example says if theta equals arctan -1 and 0 is less than or equal to theta is less than or equal to 360, find theta. So this is important. We're only looking for angles between 0 and 360. And they're using arctan. So that actually means, if you were to write this, what you would put in the calculator, it would say theta, so our angle measure, equals tan -1 of -1. So you can put that into your calculator. So you would push second, tangent, and then you would put -1 in and close your parentheses. And then you'd hit enter, and it would give you theta equals 45, so that's 45 degrees. Now, it's important to remember that in the unit circle, bad circle, there's two places where tangent equals 45, or where tangent equals -1. So there's the 45-degree angle, and then if we recall, all students take calculus, so there's also another one over here where arctan is -1. So if this is our reference angle, we also have one in the third quadrant, so you would do 180 plus our reference angle of 45 equals 225. So our two angles are going to be (45 degrees and 225 degrees. For the next one, find cosine of arcsine of 0.6. This is basically just being put into your calculator. So you can put the whole thing in your calculator. You can put in cos, and then it opens a set of parentheses, arcsine, or sine -1, and it opens a set of parentheses, 0.6, close them both up, hit enter, and it will give you 0.8. Now you could do this piece first, and you'd get an angle measure of 36.86989,765, and then you could do cosine of that, but I don't see why you would want to do multiple steps. Either way, you're going to get down to this 0.8. And the last one, if theta equals arctan of radical 3, we want to know what is theta in radians. So, what you need to do is first you need to find theta. So, we have theta equals tan inverse of radical 3. So to get rid of addition, you use subtraction. To get rid of subtraction, you use addition. Multiplication is undone by division. Division is undone by multiplication. Squaring is undone by square rooting. Square rooting is undone by squaring. And now you have three more that you can add in there. Sine is undone by arcsine. Cos is undone by arccos. And tan is undone by arctan. So you're going to take the tangent of both sides. That is not what I meant to say. I apologize about that. What I actually meant to say was that tangent of theta is equal to radical 3. So you would do arctan, that's where this was coming in here, is now you would do arctan to get rid of that. So tan -1 of tangent is the same as tan -1 of radical 3. So these two here would cancel out, and you'd be left with theta equals arctan of radical 3, which is 60 degrees. And then you would convert that into radians, so you do 60 times pi over 180, and you would get 1 pi over 3 when you reduce it. So that is your final answer. And I know that's kind of confusing, especially because I made a little mistake there. We will do a couple more of these in class tomorrow, but my video is almost 20 minutes long. I know that that's kind of a long video, so I apologize. I will talk to you tomorrow. If you need to look over any more pieces of this, make sure you do so.